Also,
Greetings, it's me who logged in with the Retos account, which is the administrator account. Welcome to Coxygen. Thank you so much for calling me Israel and Dillon. All right, let me assist you. Where do you need help?
so you said something on WhatsApp that about the script, the 3 out of 5 signatories for withdrawals. I just wanted you to explain to us exactly what you mean by that.
All right, if you go to Lawrence's examples, you still have those Lawrence's examples.
No.
There is a multi-sig. All what you do, even using the same scripts that we have, let me share and give you some ideas so that you see. Coxylib has got the smart contracts where you can send header to the smart contract. So I want to show you using Retos account, FTP account there. It is not difficult, né? That is one thing I want you to know. So this is the donation app. It's working fine. Let me make a copy of this one so that I download it. I think it will be better you use a downloaded copy. I don't know, maybe Rito is also working on it. She will find it changed and then she might complain. So what I'm going to do is I'm going to download this and then use the demo account, this one. Let me bring up that donation. So if you want, do you have a copy of Rito's donation app?
Yes, send it to us.
Right, if you have it, it's fine. And, let me where did I download it? So there we go. Right, let me change it to today's date so that okay, no. Let me first unzip it. I need that thing is very easy. The thing I'm asking you to do, it is very easy, né? It's a matter of, you will see, it's very easy. Right, here's the donation app. Alright. I'll use it the way it is, just for you to be. Today is what? 18, eh? 20. Then 2012, 2024. So All right, let us run it here. All right, so this is the latest that I have, this one. Everything here is working fine. The only two things that are missing. People are donating, they can see we are donating. Let me test it before I carry on so that we are sure this thing is not broken. But I'm going to use test one account with you. Test this one here. I don't have that donation app. So I'm going to say Xmas donation, Xmas, oh no, donator, then Xmas at Coxygen.com. Then I'm going to donate 3 Ether. Right, let's hope this works. Yeah, first part you can see is working. But look what it is saying now. I am gaining this. Zero transaction. I don't. There it is. It is going to send 3 Ether to this. You see, this is a hard-coded wallet. So let's look for this wallet address. We are on 12. Is 12. Right. Here we are. 20. Where is 2012? Yeah. Uh, I need to reload. 2012. There we go. Right. So we go to the index. I don't know where is the code for. Uh, so you can see this is I'm right. Do you see where the 3 eta is going to? It's going to this. That is not correct. So all this is going to change. All this is going to change. Okay. You see here, this line that makes it run. Let's comment it out. But before we comment it out, you can see it's working already. Let me finish it. Sign the this. Right, I'm not receiving a message. I'm supposed to receive a message, so there is an error there. Caught in a promise. Then wallet could not send. See, that wallet has a problem. So let me select another one. Okay. What makes a wallet do that? I have no idea. Let's try that one. New one. That also is not going to work. It must show a red minus 3 eta. Mustn't show all these other things. Let me go there. That is going to work. It's not going to work. Let me start all over again. I'll select another one. 3 eta there. Yes, it must be like this. Do you see? It must say minus 3 eta. So I don't know how to catch that error. That error is caused by a wallet address. If you can see, I'm on admin now. Let me go back to 3 eta. Test 1. That was test 1. We must have a way of fixing this on the right. Let me go back to put 3 eta. Do we put 3 eta or we put 3,000? I think we are putting 3 eta. Ne? Let me
So are
check.
you sharing your screen?
Now it's correct. Do you see the same account that was failing before? I reloaded the page. Now it's all right. So what caused that? I don't know. So let me, because we need to know what is causing that. When people are using, they mustn't just have such errors. We need to fix these errors. Right, I'm going to start again. I'll use Xmas donor. And then this, put 3. All right, let me run it. Do you see now is correct? So that error is misleading. We need to tell the people that if you meet this error, try reload your page, send something to your account. So reload the page, web page, comma, select another account or send test data to your account, to that account. You try all these 3, one of them will solve it. Send yourself test data. So that is how you can solve that. So now let me sign it. And we should also tell people that it must show a red minus 3. If you are donating 5, you are losing 5, so must show minus 5. If it shows I am gaining money when I am donating, then there's something wrong. See, this one went through, which is what we expect. Then from here, We click OK, and then we get this now. This one now is correct. It's working fine now. Because you see now, it automatically is giving me a donation app, and it is running fine. Then here, let me sign. Right. If it doesn't pop up that, then a person must manually get the donation app here. Let me see. See, users are not going to be coming here to check this again. So you can see the donation app failed. So this is where now we need to tell people that they must click that is get the donation app manually. You see, this is wrong. So now it means they have to reload uh, and then wait to see their donation. So when you see your donation here, then you must get your donation app by clicking here. This should work. Normally there must be a pop-up box to tell me it worked or it didn't work. So there's an error here. But it did work, you can see. I don't see where the error is, but the says mint is not a function. But I think it worked. Then let's check here under transaction. Yes, you see. So now I got an asset. So if I come here, which one is the donation app now? Yes, there it is. So I got this donation app. So again, if somebody tries to get a donation app when he has done one, it must not allow that. Otherwise, I'll keep on adding donation apps. For example, I can get another one. So people will keep on adding donation apps until they have 10 of them, which is not correct. Do you see, it's allowing me now to get a second one. You will see I'll have two now, which is not all right. Let me show you. Should be coming. There is coming, you see. Now I've got two of them. And do you see I've got two separate donation apps? It means they've got different what policy numbers. 92E. I didn't check the code for this. Do you see this one is C46? Now there is a problem there. If people are getting donation NFTs with different minting policies, then it's not all right. For example, if I want to count now how many people donated here from the start, how am I going to search if they've got different minting policy numbers? They must all have the same minting policy. And the minting policy here must be equal to the script that is receiving the money from here, so that we don't have fake donors. If we are giving people coins, fake donors are going to get, they're going to create fake accounts. All right, so how do you improve this? This is where you guys, you come in. Right, let me show you. So I'm going to comment out this here and replace it with a script now. Log, test, enter, log and unlog, so that we can send money to a script. So let's go to the Coxygen. Where is the Coxygen here? All right, here. There is a log and unlog. You need to bring it here. So open Coxygen scripts. Where is this? Yeah. Search for log or unlog. There it is. So you can see this one needs a vesting script. There it is. Log and unlog. So for you to log, you need a vesting script, give an amount, and a message for withdrawal. This will be signed by one person, but I'll show you how to make it get, get signed by two people. So right, you can follow me now. I'm adding this to the Coxygen here. So you'll need unlog to test. I'm not creating the UI. So let's go down to that place that here where I am. Right, let me create a variable. LCK equals await. Then I call this function. Remember, I need to give it 3 parameters. J.log log LCK. So this, we need, the first one is a script. So here you need to import the script. Let's get to here where we are importing it. Yeah, there it is. So here we are importing this mid thank you script. This one is working. So you can see this script is working. So here you call it, I don't know what name you call it. If you call it donation, I'll show you. Once you call it donation script here, uh, then you need to name it consistently. Then you must see now. It is in the scripts folder. Scripts, script, scripts. I don't know. Scripts. There's an S there. So you go to the scripts now here, and you create that donation. So you see what I do. Then say 20. Then I open it now. This is now the on-chain part. You export const that donation, say equals. You use backticks, 2 of them. You don't use quotation marks for the script. You use backticks. So now we copy and paste a working vesting script. Let's take this one here. We create one, or we take this one. Right. So now you need the playground. Helios playground to test the script syntax. I have already a vesting script. There it is for donating, but this one is a deadline. All right, so now let's use this one. This one, let's simplify it. This one is a datum where we have the creator pub key hash. What are we using the creator pub key hash for? Let's check here. Signed by datum beneficiary. Here the creator, the creator is cancelling this, must sign. So we need this creator on the datum. Okay. Right. The next thing for now, I want to remove the deadline on the script. The beneficiary. In the script here, we are saying we need a one person who is going to withdraw this money. Okay, for now. So this is where we can say we need a list of beneficiaries. For now, let me show you. We can say I want to make it manual so that you can understand. Then later on, you will need a list of signatories. So this is the person, this is where the money will go to. So let's say, for example, this is the person who is going to withdraw the money, beneficiary. And then after withdrawing the money, this person is going to distribute it. What about if you want beneficiaries to be 2, 3 of them? This is where now we can have a list. Beneficiaries. People who are going to receive the money. Okay. So you can show them by this to say it's a list. Right. These are the beneficiaries, which means people you are going to put their wallet addresses. They are the ones who are going to receive the money. So let's start with the one. This is the person who is going to receive the money. Okay. But now the signatories, we need 3 people who are going to sign out of 5. As you are starting, you guys, you can have a list. You can have a list here of signatories. So I can say signatories. Then here you add a list. There are many ways of doing this. You can check how others are doing it. Right, here I've said signatories. So if a signatory is not here, this person will never be able to sign. Once we put this on chain. Now, when this beneficiary, you are withdrawing the money, you can stipulate how much amount so that not all the money goes out. So here it could be amount loveless. So here int. Right. Now where is the logic for this? So when you say claim, I've got claim here as a redeem. So here we can say withdraw. Doesn't matter what word you use. So these are the people who are going to withdraw. So this action of withdraw, we start now creating the rules for withdrawing here. We are not going to use the rule for time and deadline. So we comment out time. We can delete that. See this time and deadline. I have taken it out. Right, let's create the rules for withdrawing together. Right, for cancelling, yes, let's have the creator. When the creator signs, everything is cancelled. Then everything, the money that is there will go to the creator. You understand this? There is one rule here for cancelling everything. The person who created this on chain comes in and can cancel everything. So you can force that by making the creator not do it alone, by adding one of the signatories here. Maybe the first signatory here can also sign here so that the creator of the smart contract sees that there is money here, then cancels and gets all the money. So you can even state that if the creator cancels, let's allow the money to go to the beneficiary so that the creator doesn't just arbitrarily cancel. So this is where now you are going to add a TX pay to. Set pay to. And then you enter beneficiary. That beneficiary will be a pub key hash. So these transaction functions signed by TX, you get to know them either from other scripts or from the textbook. So if I check escrow here, signed by, that one, we know that function. But let me check market for more of these functions here. Right, here are the functions here. tx.value sent to, value sent to. And then you can see datum, seller pub key hash. You can already see I made a mistake there. If you are following, you can see that I've already made a mistake there. So what I wanted to write was number one, value sent to. Okay. Let me check another function here that we may use there. There are only two functions here, value sent to, signed by. Okay, let us open the Helios book. Then we go to the transaction TX. This one. This one. Right, go to the functions. Built-in transaction TX transaction. Uh, signing and submitting. This is signing, submitting a response wallet TX8 signature. See now, there it is. A wallet hangs. I don't know what is that. Where are those TX? Let me say value sent TX. There it is. What is the? Oh yeah, still there. It is correct. It's under transaction. Built-ins. It is our language is built-ins. The class is transaction. So let's look at the functions and which ones you can use. Under the transaction TX, you have got inputs, reference inputs, outputs, fees, minted, dissets, withdrawals, time range, signatories. You can use these signatories. You can see signatories means what? Is a list of pub key hash. So you can say I did not write the list correctly. So let me correct those mistakes that I see here before I go. Right, let's go back to our vesting. First thing is if I need to say list of signatories, you must put this array before. So here it will mean signatories list. When you are creating this datum, you need to supply the people who are going to sign before it goes on chain. Okay. So I've corrected that. Let me correct the other mistake down here. Do you see I declared a datum variable datum? Down here I said beneficiary is going to crash. If you want to see, you click here. Do you see here? It's already telling you that there is a mistake on line number 26. Because here there is a mistake. Because there is nothing, but still there is another mistake. So number 24. This is the mistake I wanted you to see. Beneficiary is coming from where? It is a field in the datum. So that is why we need to say datum.beneficiary. So I have fixed that. It says TX pay to value sent to. Let's look at all the methods of a transaction down here. So you can see we can call this TX signatories dot contains. Then we have those ones. Right, let's go to the methods that I want you to see. Is underscore signed underscore by that function. You saw it. You need to enter here a wallet address pub key hash. You take the batch 32, you convert it to a pub key hash. You can ask me then, how do we do that? We have a function that does that. If you go to the Coxygen there and check address to page 32, you will find a function there. I created a function that does that. Right, I can say this one, pub key hash. There it is. Base address pub key hash. When you call this, it gives you the pub key hash of your wallet address. When you call this function, it gives you your batch 32 address. It will give you this address on your wallet, which you receive. When you click receive, it will give you this. But now, when you want this address in a pub key hash format, you call this base address pub key hash pkh. You can see they take this base address and then calls the pub key hash function, then it converts it to a hex. That is the one that is needed here. This is what they mean. You don't supply the wallet address batch 32. You supply the hashed format of the batch 32 address. Here, our signatories are going to be a list of these wallet addresses in a pub key hash format. Hashed. Right. I think this is very clear. Right. So now I fixed these errors here. We need to add some more logic. Right. Pay to, which is line 24. Alright, this is wrong. Cancel. We wanted to say value underscore send underscore to. You can check here under the functions of the transaction. Output sent to. Okay. Output sent to that home. Outputs logged by. This is a script. Here it is. Value paid to. On the other hand, I'm looking for value sent to. How are these two different? This one returns the output value sent to a generic payment address with a specific inline data. What about value sent to? Returns the output value sent to a regular payment address. That's not what we want, because for us, we are looking at value sent to a script. So this is what we need. Returns the output value being logged at a given script. So we must use value dash logged by. See. So this one, it's when we have a beneficiary. It's correct, this one. This one is correct because it's a beneficiary wallet address. But now, if we want value logged to a script, then under withdraw, maybe. This one is correct because it's not a script, it's a wallet address. Sorry for that. So here, value sent to. Let's check now. Boolean and value undefined. 23. Oh yes, sorry, I didn't finish here. Value sent to. Then here I can say loveless is greater or equal to 1. Right, let me explain here. This value sent to is going to give us back a combination of data and tokens. So that is why when you look here, it says you are going to get value. But what is value? you will see here, value refers to two things. The first is the loveless. So value has a function called loveless. This extracts the loveless from the value. That is why I said dot loveless. So I just said value dot loveless. So this loveless from value, it will give us the eta in million. That will be in million. Get love. Sorry. Yo, I'm a little bit tired. This thing of working at night. We're supposed to say get loveless. This thing of working at night. I'm tired, guys. This is not correct. Supposed to be get loveless. Get underscore loveless. This is the function. It's a function, this one. So I think we need to put parentheses. Let's check that it compiles. Get loveless undefined value dot get loveless. Let me check here. Get loveless undefined. Let me copy this. I'm not sure which what mistake I'm making here. Value sent to datum dot pub key hash. Then we say get loveless. What is wrong with that? It says left hand side not an instance of. This is line number 24.8. It's correct, man. When you have got some problems like this, to check whether you have used this correctly or not, check some of the old smart contracts that you have where you have used it. There is a little bit is here value sent to at atom price. This gives us a value, okay? Let me just check again where I use loveless so that you see how it is used correctly. Let's go down. Right, let's check here. It says expected value. Get assets. If you want tokens only, you use get assets. So this get loveless is correct. Maybe we have to change the way we are using it. Right, let me change the way we are using it here. Let us first declare a variable here.
So your
Yes.
your lab is not in a function format. Your get
Uh,
lab this. It's not a method.
come again.
For your script. So for you when you said get lovelace, you didn't put brackets after, or there's no brackets after.
There must be brackets, but that is not what is making it fail. When I put brackets, it still complains. Oh, yeah, you are right. 100% right. It was supposed to have these closing brackets. I'm tired, man. Now it's working. Do you see? It has compiled. What does it mean? It means here when someone is canceling, it must be the creator. That is the first wallet address that deployed this. And then number two, the money, the value, here is the money, the loveless, which is here. It must be greater than 1. Okay? Now, we want to say this must go to the beneficiary. Okay? So how do we do that? So this one, it will give us the money. This will give us the money. Okay? That is there. So it will allow the person to cancel only if now there is, actually I can't say value sent to the beneficiary, which means the beneficiary is going to receive loveless that is greater than 1. That logic is stupid. But I'm just showing you here. You need to create valid rules. Each of these that you see here is a rule. I'm putting rule number 3. What I want to say is the value that will be locked by the script must be sent to the beneficiary, not the creator. Okay? Then this can be cancelled. But a practical situation is the people who can cancel this must be the 3 signatories that move money. That way it's safe. Then the creator must be one of those 3 signatories. That really makes sense. You need to really work out the best rules to prevent your money being stolen. Here, what I'm basically demonstrating to you is how to create those rules. I sometimes separate it like this. Put here like, you see the end, separating like this. So that you see here, for this cancel to run, you need 3 rules. 1 must be fulfilled. If it's not, then it won't release the funds. Second rule, third rule. You can manually write down your rules. Then come to me, then I come here, I build up on-chain script for you. Right, give me 2 seconds. I just want to go. I'll be back. I'll be back. Just,
All right, sir.
And for some reason, my internet, or is it free conference? It's freezing the screen.
I think it's your internet.
It can't be my internet, but because I'm running smooth. Maybe it might be, yeah. But
Because
then,
I'm seeing everything. I've been seeing everything has been doing. Mine has not been cracking anything.
the thing is, like, each time when maybe he's moving a cursor, it might freeze like a frame.
Yeah.
Uh, is it my internet? It can't
I'm
be.
using your PC.
It can't be my internet. Could it be? Let me check. Nah. Yeah, wait. Mm, Check. Yeah, I think it's my laptop, because my phone speed is okay. My download and upload speed is okay. I think it might be my laptop. Yeah. So like, okay, the beneficiaries and the beneficiaries, the signatories. So okay, let's say if it's cancelled, right? Do each one of them have to like sign the smart contract?
Yep. Sorry, I didn't hear you.
Oh, okay, I'm saying the signatories, signatories, is it?
I wanted to ask him. The signatory is it three people?
Right, I am back. Before I carry on, I think it's good you ask questions.
So
Here, what I was basically showing you is how to create the rules of the validator. Once the rules are created correctly, then this, you put it on that script. We said the name of the script is what? Donor, or is donation.js. So you must change this spending to say, instead of vesting, so now we are going to call it donation. Okay, so there it is. Yeah. Questions from your side?
so when you say signatories, you mean three people must sign?
Right, this one is going to contain a list of signatories. I will show you on the off-chain part. When you are creating the datum on the off-chain part, let me show you. Bool and int undefined 27. Okay, all right. Yeah, this one here, I didn't finish this one, but I'm coming to the log to the other side. When we are using the unlock or the log because you create the datum when you are creating the log function. So when we create, so you will need, because remember this is the generic log function. So for you, you will need to copy this function and add those other features on the datum side here, which are not there. Remember, I just gave you this probably as an example. Let me copy these fields. We've got 4 fields. So when you create this off chain part, this is where you must apply these 4. I'm putting them here because we are coming back to create the what? The datum. We are going to add these ones here in their numbers. This is going to be number 1, number 2, number 3, number 4. So let me get this to run so that you see it from this side. Right here, I wanted to create a rule to say maybe 3 people sign and that money that is there goes to the beneficiary. How do we do that? We have got a value sent to get Loveless. This gives us the Loveless amount. Okay. It must be the value logged by the script. If you remember, there is another function for the transaction TX which says value logged by logged by. Keep on checking. This, what do you call it? This value logged by. Keep on checking on the book, or you can use this other. Where is that value logged by? Loveless. Right. When you want to find it very quickly, that is why I like this get assets, get Loveless, get safe, get policy. Just type it here. Say value logged. There it comes out. Value logged by. Yeah, I typed it correctly. So this one, value logged by, you must give it a script validator hash. What we need here, we want the money, all the money that has been logged on a script to be given to the beneficiary, whether the creator signs or the 3 people sign. That is what I want. That is the logic I want, the rule I want to put. So I'm going to use that value underscore logged underscore by. Let's see if I did it correctly. Value underscore logged underscore by. And then here I must give it a what? A validator hash, a script hash, the hash of this script. Now, may ask me, where am I going to get that script of this hash? You have to create it here using this script context. See this script context. You have to create it here. Let me show you others that have created that. Let's come to validator. Here it is. There it is. You see the script context. It has a function called get current validator hash. you can find the methods of the script context here. When you say script context, there, click it. Look for the function for that one. I'll show you your spending methods, serialize, get spending output ID. What we want now is this one. You see the method. Here, what I'm also trying to help you is to teach you so that you don't get lost. How you use the book or you use the other examples to just put together your own chain code. It's very short. Normally the on chain is very short. It's not too long. So there is a method, a function here under this class. I always call it a class, script context. So if we come to our donation here, we need to declare it here. So our script context variable is called context. There it is. So that is the one that we use. So we need to create a variable. This is how this Helios on chain creates variables. So here I'm going to say SVH for script validator hash. This is a variable of a type validator hash. So there is a type validator hash. If you are not sure that there is such a type, come here. You'll see where I got that method. They said it gives you back a validator hash. There's a capital V, it is a capital hash. This is a type, right? That is why I'm writing it down here. If you don't do that, this will make an error. It will throw an error because it wants, when you create a variable, this is how you declare variables on the Helios on chain. Just write the name of the variable, but you have to give it a type. What type of data is it going to receive? So you put a colon there, then you keep it, you put a type. So in this case now, we then call out on the context dot, you see that function, get underscore, current underscore, validator underscore hash. Then you put those, then you need to put semicolons. That one is important. Before this sign here end, before this, on the rules, you don't put the semicolon. Semicolon, you put it here. You can put it on other statements here, but on the rules themselves, because it is going to look at this as a one expression. This and this and this or this is one expression. All right, I have explained to you how you get your what? Your validator is. So here we wanted to say the value logged by the validator hash, the variable is SVH. Now this one, this value, has a loveless. It's the money that is logged there plus the tokens. There could be some tokens. You know, when other people who are donating, they might donate tokens. But in our case, we don't care about the tokens. We care about the header. So we say get loveless. What we did before. Say the value logged by get loveless. Then we say it must be equal to tx value sent to this get loveless. So let me ask questions if you are getting confused. If this site is saying the total test data that has been sent and logged on the script, the loveless part of it, because remember it's an asset, must be equal to this part that the beneficiary we stated here is going to get. So we've got three rules. This one's a stupid one, leave it like that. We don't want, if this is 0, then this one's 0, then you have to waste time. So this one is important. The creator is the one who signs. Created this but can cancel this. So this is one rule. Withdraw. Who is going to withdraw? Is the beneficiary signs. Now, for now, if the beneficiary at any moment opens the wallet, because the beneficiary wallet address is here, blockchain knows about that because it will be here. When this goes in anytime there, it can withdraw the money. You can sign, and then that money, it will then run, spend, you take, so then the money will go to the beneficiary. We might not want it to be like that. We might want the beneficiary to sign, but we might want, remember, the other two signatories to sign to make sure, yes, we can sign for this money that you want to get. We can even specify here the quantity, how much this guy or whoever is going to get. We can say here, value locked by get loveless is equal to this, or we can replace this by an amount. Let me say tx value sign get loveless of is equal to, I will put a percentage, 0.25 times this. So what this means is, at any moment, beneficiary can always get 1/4. It will take this amount, divide by this, and then it will allow that money to be sent to the beneficiary. So which means if there is 1,000, they will be withdrawn going to this same person 4 times, 5 times. But we might want to pay more than one person. So this is where we can allow that by making this an array of beneficiaries. So now you see it's an array. So which means this is going to crash, because this now, it must state which beneficiary. So we need to now find the beneficiary in a list. If I'm hard coding it so that you see, I can say beneficiary 0. That will be the first beneficiary wallet address. So if I say 1, it will skip paying the first beneficiary on the list. It will pay the second. But what happens if the second is not there? This is where now you need to check that this list is not empty. Number 1. Number 2, check that this list is at least 2. Because here I want to pay number 2. So I'm showing you here that you can pay more than one person. It's the same here. This will crash because now this is a list. It will crash. So you need to specify. You can say, all right, the first a beneficiary will get 25, and then add another rule. The second beneficiary will get another 25. I'm manually doing this. Let's edit here. Please keep check if I make a mistake. Help correct me. Then now, you see here, I'm hard coding, which is bad, but it will help you because you are starting this thing. You're learning this thing. So here it means the second beneficiary, there are going to be at least 2 people who are going to benefit from this. So they will get 25, 25. Then what will happen to the rest? Leave it there. Or if you want to add other beneficiaries, or you can give the rest to the creator, or you can leave it there, because remember it's after the what? After the donation. These beneficiaries could be those who are getting 25%, 25%. Then the rest, let's give it to the owner, and then the owner is the wins treasury. I'm just giving an example here. So here now we say 0.5. So now you know what this thing will do? It will calculate 1/4 and make sure it goes here. Now here, this is where I can say creator. Get Loveless off. So value sent to creator must be 50% of what is logged on this validator hash scripted. So basically here what I have shown you is how to create validation rules. Very simple in Helios, because you can actually see the logic flowing left and right, left and right, left and right. This one here. Right. For the withdrawing of money, this is when we cancel. What about when there is withdrawal? Okay, when there is withdrawal, we can allow any of the beneficiaries to withdraw money anytime there is enough money, anytime they want. How can we allow that? We can say the beneficiary signs, okay, which means remember now which beneficiary signs here. So we have to specify here using here. But remember, we loop. You have to go to the book and see how we loop. Use map. Find this beneficiary, then add the logic. In this case, I'm going to use it in a very simplistic way. I'm going to say withdraw must allow the transaction to go on if the first beneficiary in the list signs and the first beneficiary in the list gets 25. See now. So I take that validation rule. If there are errors, let me know. If the moment you see an error, let me know, because I can make a logical error. But as long as you will understand the rule of constructing, I think we can move these here so that at least they are not too far. Okay, all right. So if we leave it like this, only the first beneficiary in the list will be the one who will withdraw. And whenever the first beneficiary withdraws, he is going to get 25% there. But that is not what we want. We want also the second to withdraw. So now, you know the Boolean logic. So here we use the OR. Okay. So here I'm entering the O, which means what I copied here for the first one, you can enter it here for the second one. And then you'll see I have to change here. Sorry for my dog. No, we've got a house dog, that is a problem. So here I'm saying this first one can do this and get 25%, or the second beneficiary can anytime go there and withdraw, but must get 25% of what is there. So, right, let me check correctly here. This is wrong. Zero, the first, you get this when you sign this number one. Then you send to number one, number two. Right, and then remember there is that 50% for the creator. Now we can create this creator. Sorry guys, the dog may be annoying to you, but for us, we live with the dog. The dog in our home has got the same rights as people.
It's okay, sir.
Yes, and the cat, but the cat comes and calls. He hears people on the laptop talking, then she wants to call also. The dog, when anything outside, she's protecting us here to make sure no one comes near. All right. This now condition for the withdrawal. So here I'm saying the person who can sign. Sorry. There is a mistake that I'm seeing here on this other value. Let me correct it here. There's a mistake that I'm seeing here. You didn't see that mistake. Oh yeah. The mistake is I need to add the signer for the withdrawal of 50%. So here it is going to have two conditions on this other part of O. So here we are going to say end. Right, transaction is signed by here. This is where now the creator has to sign and get the 50% of what is there. So datum creator signed by, you see here I'm saying the transaction must be signed by the datum dot creator. Then down here I'm saying end. Let's have the 50% of what is logged there. That amount must be equal to this. Sometimes what I do, I put parentheses to make things very clear. So this means this will be executed, and then this one will be executed. Then the two will be combined. You know, the Boolean operations. Right. So this will allow the following.
Sir, I think you made a
Yeah.
mistake.
Come again.
I think you made a mistake.
Number 27. Right. It is saying there's a mistake on number 27. Invalid type syntax. Where do you see the mistake?
Oh, the one I was talking about was the last line. 47. Yeah, you put too many brackets. I think it's also supposed to be one bracket, two brackets.
Let me check brackets here. Why is this not? Loveless. That one is for the loveless. Then you see this bracket here. That is for the loveless. Come on, man. All right. Mm, all right. I think you were right. Let me check again. Yes, you were right. So I need that bracket. You know why? The last one is for this one. This one here. There is this one here. So I need
Yeah,
that.
but then the one for the. Oh, okay, I understand.
Check it properly. Do you see?
Oh,
If
okay,
I
I understand.
put it, do you see here
Yeah, yeah,
already?
yeah, I
Compiler
understand.
is an error.
Yes, 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 yes.
So when I put it, it shows. All right. Okay, let us check. You know, you need to have correct logic for this to work. Let us check our datum. Our datum. Our datum has 4 fields. The first one is clear. The second one is a list of beneficiaries. I said beneficiary, I could have said beneficiaries, but doesn't matter. It's a list. In this case, when you see here, we have got 2 beneficiaries, 0 and 1 on the list. That's an example. Get us going. And then the second one is a list of signatories. Right. Then we might ask ourselves, since the beneficiaries are the ones who are going to be the signatories and signing, why are we having the 2 lists? Yes, we can get rid of 1 list. Beneficiary signs and value sent to the beneficiary instead of saying, right, because I haven't used the signatories here. If you look at here, I didn't even use the signatories. Right. How do we use this a list of signatories who are not beneficiaries?
I didn't know the
Right.
ones that you just thingy.
No, the beneficiaries are those who are going to receive the money. But I also
Yes,
said
but then
for
the
signing.
signatories are not the ones who are sending the money.
Remember when I'm withdrawing the money from the smart contract on the app, my box will pop up for my own signature. So the beneficiary will have to sign for that transaction to go through, for the money to go to the beneficiary's wallet account. But we want the administrators, 3 signatories out of 5, to approve that payment. So they will need to sign also as an extra condition. Now, how do we get the signatories here? One way is we say we pull out the signatories from the list of signatories in the transaction. So let's go to that transaction. Michelle, come, my boy, come, jump. Okay, come here, come here. Don't worry, sit. All right. So we can use the, remember when we are here under the transaction, we have got a function, this one which says signatories. We can use this one. If you look at it, you will see immediately that we can use this one. So all what we simply do, we just say TX signatories. So once we say TX and say signatories, returns the list of explicit transaction signers as an array of pub key hash. That's exactly what we want. If you look at our datum here, that's exactly what we want. So let's add this. When it's cancelling, we put too many rules for cancelling this, but it doesn't matter. Let's edit here. We can edit both to the cancelling and to the withdraw. So now if you look at cancelling and withdraw, the rules are almost the same. Then one person might ask, oh yeah, that one requires a creator. It requires a creator. A withdraw doesn't require a creator. Oh no, it does require a creator. I don't know. I think there's something wrong there. I did. This is where you need to put in a lot of thinking and correct the logic. But I will carry on here. Add 3 out of 5 signatories there. Okay, let's come here. Right, so let's create a condition here. This gives us a list of signatories, people who are going to sign. So we must make sure that any of these signatories, right, we get 3 out of 5. How do we get 3 here? It will give me a list of signatories. So I can just say, the first thing here, I can say this must be equal to our datum, our signatories here. Right. Here I will say datum dot signatories. Okay. So which means here this list must be equal to this list. That is another way. So here I've got a list. If I put 2, people are going to sign. But in this case, I want 3, not all of them. So I think there is we need to put a logic to say 3 of these not equal. If we say equal, if here there are 5, then here we need 5. No, we don't need 5. We need 3 out of 5.
Since it's a list, isn't it possible to look through? Isn't there like the thing that allows you to look through the list to return 3?
Yes. You are right. But remember, we have to put it in the syntax the compiler for Helios is going to accept. I want us to work it out without checking. There is a multi-sig Helios example by Lawrence. Helios examples, Lawrence. Alright, good people. To be honest, for me, I normally don't work during the day because of the noise. That is why I work at night. Alright, so here is this one here. Let us go to This example, pages, API, get signer, Angular. I will give you this link because you can see here there is get signature. It is implementing that same thing here. The NFT multi-sig. Where is the on-chain part? This is the off-chain. Sender submits wallet info mint higher sign. Where is the script for this one? No, this one, that is not a good example. The donation, this one, I think is similar to the one we are just creating. This here is an amount ID. Here to hard code, mention pub key hash, donor pub key hash, refund pub key hash, administrator pub key hash. You see the way he did it here? He had to say, you have to supply these 4 pub key hashes, the addresses. Then he had to do a split, 90% go somewhere, 10% go somewhere. Let's see here on the spend, how to spend. Right, list of transaction, how to send to. If you want to have a look at this, I can send it to you. It says the head value, whatever. This is not what I am looking for. You can tell me, we can create it, it can work. We have a list of signatories on the datum here. So our datum here is a list of signers. There are 5. We want 3 out of 5 to be one of those that are going to sign the transaction. Right. This is what we do. This gives us the list of those that are signing. So here we can say dot length, because it's an array, is equal to 3. Okay. And these 3 who are signing must be part of this. So how do we do that? Maybe do we have a method called contains? This is where we need to check. We need to check that a subarray is contained in another array. Remember, there is in JavaScript subarray in another array JS. So we can say check. You will see here there is either includes or contain. Contain. This is JavaScript, but remember this is not Helios. We are then going to check with the Helios. So you see here JavaScript array can use contains or includes subarray. Now what about Helios? Is Helios using the same syntax? Right. Includes. Actually with JavaScript they join into a string They join the other one into a string. That one is, I don't like that. I'm very sure it's a string of another array. Yeah, I'm not getting this. Index of. We're using index of. Right, now let us go to Haskell, Helios. Right. I agree with you. You can loop, like for example, you've got two arrays, a subarray and a big array. You loop through that smaller one, 3, and check that all the elements on the smaller one are on the bigger sub array. It's like sets, sets. Elements of set A are all
Yeah.
subset. Set A is a subset of B. It means all elements here are there. Now, we need to figure out in Helios, how do you do that? So we have got a function map. Okay, we can use this map. Oh my God, these people are not finishing up. Right, the implementation of map here. Michelle, come. Michelle, come, Michelle. I was thinking this thing was going to be short, but it's taking too long. Right, we have got filter, find say, find key, say, find value, fold lazy for each. Yeah, there we can loop with this for each. We know how to use this, the for each. Right, we have got I set something for each method and returns for it. No, map get is empty map. Right, here is the normal map. So here we are going to say signatories dot map, the key, the value. In that case, we only have got keys. Only one element. Guys, I have a meeting online. Please. Sorry for that. I'll finish now. There is a set. Maybe this one is we can use a set, the first entry with a given key to a new value. You can check it out. This one, map key, this one. Show sort update. For me, the best list method you are going to use is map. Very sure you can use one element here to compare all of them and to make sure those signatories are part of the datum signatories. Let me see the list methods that are here. From data new const getters, tail, operators, all any. This one is interesting. List.any. Filter. Find. Yeah, I think this one returns the first element in the list that satisfies the predicate. Now, the other thing that you need to do on chain, you need to be very efficient. Otherwise, you'll pay a lot of money to put your code on chain. And then again, when it is executing, the more it does more loops, the more it will cost people more money when they are running. So you need to find the most efficient way of checking it correctly and safely. Fault. For each. I think for each is what we are looking for. But now, for each part returns nothing. You run through the for each part. It will force you to create a value that you will mutate here, so that when it finishes, you check that value is true or false. Then I can use this one to show you how to do it, but avoid mutating. That is one I can use now. Join map. Mapper item. One thing I have realized is the normal syntax for JavaScript we are used to, when you come to Helio on code, it fails. It's similar in the sense that you see the curly brackets, similar, but the compiler here is completely different. Let's use this one that I have. And then from there, remember, we can always improve on it. Okay, let me use it here. Right, we are going to say list dot for each. So here we have got this a list of signatories. So TX signatories. Then we call for each. Right, and then from here, item type. So here under item is a pub key hash. So you can here, what is the item type? It's pub key hash. Yes, this one I think is going to return nothing. And then the implementation of this. I've not seen this used for each in this Helio site. We have a function here. So this function is the one that we are using. All right. I will comment out this one and go and check it out. On any of these, I have not used the list. This situation we are having, you can check here on the datum. I don't have an array, I don't have a list. Things are just straightforward. Which one was the most complicated one here? None of these have the list. The vesting. What about the English auction? See, I don't have even this list of items in the datum there to look through. Then, so that we have got an idea on how to look through, I'll tell you why we have to do it, because we need to provide Helios with as many different examples as we can. That is why we are getting our proposals funded, because we are solving big problems. And now, the good part, we got another proposal funded. But now, it's no longer going to be one or two universities. Over 16 different universities are going to be working. Right. I think we need to figure it out so that we can teach others how to do it. Please, I will leave it to you to figure it out. You are very clever. You can find it easy. The answer is use this map. Here is an example here. Here is an example. We have got a list 0, 1, 2. Map, get 0, sure. It prints 0. But how about, you see the problem with this documentation of Helios? There are no examples to show you how to use this function. You might just try to use it the normal way you use JavaScript. Then it fails. Then you don't know where to correct. This is one big problem with this one. You don't know how to construct because there are no examples. You can't. It has always shown me the map here is different from the map on the other side, on the JavaScript or TypeScript side. Here it says the predicate. What is the predicate? Number two, how do you construct that predicate? There are no examples. Find. This returns a tab. I will tell you what caused this. What caused this is when they were creating these functional programming languages on smart contracts, they were following Haskell Bluetooth. That is why sometimes if you really want to understand this map correct, you go to the Helios Bluetooth. But then that one, it has a different syntax altogether. That is one big challenge. You can be stuck for a long time. Find safe predicate. Retains a callback that returns the found key value pair and a boolean calling the callback if the returned bool is false throws an error. All right, give me time. I'm going to check. I've got two, a map, and then we've got this one, for each. I'll play around with the for each up until I get it working. Only problem I have with this for each is not returning true or false. It's returning nothing. Map.getKey, return type, getSelf is empty. Map, new key type, new value type. In our case, the list of signers is not a key value. It will just be a list of pub key hashes. Then the mapper. Says the first entry. All right, just give me time. I'm going to find a way around it. as I've always done. I will find it for you. So which means for now, this is what I do until I find a solution. Then we limit the way we have done it here, which is not a good thing because now we want to use it in real situation. We are going to limit the number of elements on this to 2. And then for now, because we have limited it to 2, then we access each element individually. It's not a good thing, but it will get us going. Right, for example, I'm going to say datum contains. Then I give it, this one is all right. Must be 3. Then we say the signatories contain, then we get the first, like this. This is correct. This gives us the first pub key hash, the signer, the first signer. So we just search the signatories contain this. Okay, this will return true if it is there. Then we check again, end, because we need to check twice. Then we say datum dot signatories dot contain, again contains. Then we check the second one because there are only 2. Let's do it this way. I know people will criticize a lot, but let them criticize. We'll find a way. How did we manage to get to where we are with this? We have managed to go very far with this, solving things step by step. Remember, the way people solve problems is different. Smart people can solve it very quickly, but slow people will solve it slowly, but at the end of the day, we will all solve the problem. We'll find the best, most efficient way. So this one is not efficient, but it will work. I've said in the list of signatories on the datum, we check that signatory on the transaction, the first signatory on the transaction, it is there. Then the second one, it checks again that it is there. It is here. And then we do it one more last time. Okay, if you can follow me now, it means now 2. Right. So I want you to think now. What is the problem with this one? It will work. It will check that the list of signatories on our datum has got the signatories 0, not the transaction signatories. The ones on the transaction side, we are going to give the signatories. So the list of signatories we are going to give there, they are going to be 3. That is why we said here the transaction length of signers must be 3, not 5. Now we need 3 out of 5 to sign. So these people will arrange offside and say, all right, out of A, B, C, D, E, B, C, D, please go and sign. So when they are constructing on the app there, they will be enter your first signature, then penny, whatever, then they enter them on the UI. And then run. Then the UI is going to allow the first one to sign. Take this transaction body signed by one person, but it won't submit it. Then it's going to give a notification, either SMS or email, to the second one. Second one goes to the app. The second one will see the first one is signed. Then it's going to sign. Then it will then send a notification to the third. Either the third gets the notification first or whatever, it doesn't matter. But when all the three, remember the signers in a bank, they always communicate, get into transport, go to the bank and sign. It's a concurrent activity. Here, on a decentralized way, we are going to store a signed body on the database. The nice part is no one else except those with the signature on the datum that is already on chain can sign. Even if I get and I say, okay, can I put in my signature there? Then it goes, it won't work because my signature is not on the on-chain datum. So this will work. So this is going to work. Number one, let me do this. Signatories must be three. Right, that one is a straightforward thing. Then if there are three and they are in a list, then we have the first one, which is index 0, the second one, index 1, third one, which is index 2, correct? Then we check here, signatories contains. Maybe one error here that can happen is signatories might not have contains. So this is where now the compiler is going to tell us when we compile now. Right, let's check. Let's move this one a little bit. Yeah, it's fine like this. Right. Then I'm going to move this inside, indent it so that you see this bracket ends here is for these three. These three must be part of the signers. They must be contained in this. Those that have been signing here. Right, here I'm happy, and there must be three. So let me then close this one. This closes this, closes here. Oh, I had created it here. If you find another efficient way, that would be awesome. We are going to find it. Because here we are dealing with three. What if it's 20 out of 30? People are playing a game and they have a strategy online. And now you have said 15 out of 30 people can sign. See, like in a vote, whatever. How will it work? So this part of doing things is not good, it's not efficient. But as a start, let's get going. That is where we have. Right, let me summarize the rules. So we count them. Right, the first rule is this one here, which requires three signatories on the transaction side built. And then these three must be on the datum signatories, which are going to be 5. There we have it. That one is the people are going to deploy it first. They will make sure that the datum signatories are 5. The problem, the person who creates the first transaction to deploy the datum has no constraint. He can put 2 signatories, then this will crash. It will never work. How do you force the person who is going to deploy to make sure that the signatories are 5? See, when people are deploying something to a smart, creating a transaction, output to a smart contract, locking something, creating a datum for the first time, there is no way to stop them or to tell them, don't do it like this. Other people create transactions to a smart contract and put money, and they don't put a datum. Then you won't collect that money. Unless, I think Bluetooth version 3 is different. Bluetooth version 1 and version 2, if there is an output that goes out without a datum, then you cannot spend the UTXO. To spend the UTXO, you need to supply a redeemer. And then when you supply a redeemer now, that is where you need a datum. So this is very strict. So here we assume the signatories are going to be at least 3 or 5. I think we can force it to say the signatories must be 5. If the signatories are not 5, then it means something went wrong on creating this, because it's a security problem. Because the moment here it says 3 out of 3, and what if immediately those that are deploying, they put only 3 signatures? Then the 3 out of 5 doesn't work. So here we can say the datum signatories. See here, length must be 5. Not 6, not 7, not 2, not 1. The withdrawal comes after when that thing has been deployed. So if they don't deploy with 5 signatures, then the withdrawal never happen. Money that will go there will be lost forever. The only way to recover that money there is to cancel the transaction. So let's make canceling the transaction easy so that whatever is there can be recovered. We can say the creator can cancel and get all what is there and eliminate all these other difficult things that we put here, in the sense that the signatories are not there. But what if there is a lot of money now and the creator collects it by canceling? We don't want that. So this is where we need to deploy it, test it, change it, test it, change it, until you reach a certain safe level, 99% safe level. Then you can start using it on chain. On production. So for now, to get things going, we will allow the creator to cancel it very easily. So to cancel it will only be the signature of the creator. That is why sometimes we even put a deadline to say they must be able to do that within a certain time. Right now, let us check for errors on the rules that we have put here. I'm not very sure about contents, but let's try. Invalid syntax 27. Alright, syntax 27. Right. Sometimes it's a 27, but it is referring to everything up to here. This is what I want to show you, how to debug this thing. Sometimes it will tell you line 27, but remember, the compiler is looking at this expression, logical expression, as one statement. It only goes to the start of that statement here. It might say 27, yet the error it is locating is here. This is how you debug. Comment out one rule like this. So just comment out one rule here. Yeah, come on. Let me highlight this rule. It's not commenting out the way I want. All right, I'll cut it out. Just say out. That rule is out. Then run it. Yes, the error is still not there. Okay. And I keep this one out. Then I remove the second rule. Second rule is this one. This one we can simply something missing there. Something missing, I see. Because you see here we said O. So this can happen with this and what I removed. So let me go back. So this O, let me take it out. It's one expression signed by the creator. So this is one. Okay, let me take this one out. Let's run it. 27. See, still pointing to 27. Let's get into the next one. Can take out the first one. It ends here because there is an O there. So this O means all this. Right, I've got this one left. There were three of them. Let me test. 27, there's a syntax error. Then from here we built them one by one. Let's start with this one here. Right, with this one here we have got signed by the beneficiary index 1. And we've got this one here. Let's put a bracket. And then we have got this one multiplied. Then let's give it a bracket. Then it means we can give this one get Loveless a bracket. Tatum beneficiary 1. Get Loveless. And then a bracket. Yes, here I need a bracket. Let's check it. Invalid syntax. Then I suspect the error is on the beneficiary, that index. I suspect it here. So let's replace this with creator. And then here with creator, just to rule out this part here. Let me test it. See. So now I know in that whole everything, what was the mistake? It is failing to accept the index in part, pointing to an element in an array. This is how we do it in normal TypeScript, JavaScript. So you can see the error is this. You see, I leave it like this here. I run it. Do you see? So we know now the error is here. So it means, how then do we index an element beneficiary? Do we have to state here that there are two? Let's check. TX, that is not allowed. So to say there are two, pub key beneficiary, pub key. Okay, so I will find out how that works out on accessing the element in a list in Helios. I'll find out. For now, I'm going to leave the code we have. We have like this, all of it. Come on, man, as well. Let me enter the last one. All right, let me come back now to you people. Then I think I've assisted you in creating the script. This one is a little bit more complicated now because we want to get into 3 signatures out of 5 signing. Yeah. I'm going to give you this. I'll send it to our code. Let's go to our code here and we paste it there. Remember, it has got some issues. But now, how do we test it one by one and see the errors that are there and improve on the errors? It's easy. What we do now, we add the helper JLog functions, and then we create trace. The normal way we do the JLog, do it here. Let me do this, then this is very important. Select one of what we have here. So I'm going to copy all of them here so that you see. So these ones they come here. Right, let me explain to you how this works. You know, when we use the JLog, we have got run true. This allows you to do what? To start tracing and logging when you say true here. So it means whatever we do, when we call this script, where we have the JLog, it will start giving us information. Now, let me show you how then do we write the JLog using this. Let's start here so that you see how it goes. Let's start here. I want to see the validator. So how do I do that? You go to the JLog that has got validator, which is this one here. So it says JLog val hash. That is the function that you use. This function will get a variable of a validator hash, and it will trace, it will log, it will check, it will run and print it. So how do I do that? Here, the normal way we do it, you can do it here, it will work. The first parameter, there are two parameters. First parameter, the normal way we normally do with the JLog, with the j.log on the other side. Here you just say svh, and then this side it's svh, the actual variable that we have here. It is something we don't know what it is. When this runs, when the j.log value hash runs, it is going to tell us what is there. So you do it on all the variables that you have. For example, here I'm checking this condition that a datum creator signed. It can be true or false, but how do I know it's true or false? Then you need the j.log. This one returns true or false. So that is why you say j.log. There is no j dot on the on-chain Helios. It's just j.log. Then this one returns true or false. Bool. You need to terminate it with a semicolon because this is the j-logging, our Jimba. Then what do I put inside here? Copy this bool line, this rule that you want to check if it is true or false when it is running. Then you copy this, you paste here. This is a string that is going to come up as a label or a description. Then this will show you true or false. This part here, it will say false. If this says false, then you know this one is false. Then you know why your Helios validator failed. What you need to know now, this one is not part of the conditions. It is a tracing and logging and testing for you. So that is why you terminate it here with a semicolon. Now, next, I'm going to test this one. I want you to see two things here. You can test this one as a whole, or you can test this other part, because this part I know it's a hard-coded number 1. So I can test this one as a whole, or I can test it in 2 pieces. Let me take this one, which has got many things, to show you how do you test this one in pieces. I'm going to take this first piece, this one here. TX value locked by. This is going to run and give me a value. So I use JLog value. How did I know? Because the functions are there. There are not many. You can read them so you know it is there. So I can check here and say, see, it says 2 out of 2. J value. I try to create a function for each value type that we mostly use on chain. So here we say value locked by. This is a string. This will be a label. But then the second parameter there is the variable, which is of a type bool. It will evaluate to true or false. Let's call it predicate. Then remember the semicolon. I have only done the first part, this one. Then now I need to do the second part. Second part is going to give me a number, the total loveless that are in that value. This one will give me the value as an object. This one will give me the integer part, which is the loveless, 1 million. So here I say JLog int. Then here is the string part. Then you enter the variable part, the one that is going to be evaluated. Remember to put a semicolon there. So you see now I have tested up until here. So now I need to also check on the other side, value sent. In this case, the SVH is tested on top. That is fine. We test here, value sent, datum beneficiary 0. Remember now it's creating a problem with this. I'm going to take it out, put creator for now, so that you see how do you go about doing this. This one has got 3 pieces. When you are testing this, you are going to test it in 4 pieces or 3 pieces, minimum 3 pieces. I'll show you. I want you to pay attention. The first piece is check the datum creator. What datum creator is being seen by this transaction? Datum creator is a pub key hash. So we say JLog, then here you say pub. Check how the pub key hash is written on top. The input, output, datum, value hash. See, pub key hash list. Pub key hash is not a full word. It's a PKH. A PKH. That is the function. Then you put a comma there. You know how to do this because you are doing it on the other side. That's exactly what we are doing. What this will do, it will give us the pub key hash of the creator, or there will be nothing. There will be nothing. Then you know something is missing on the off-chain part. Now let's go to the next one. The next one now is I want to see the value. So here I'll say JLog. I've done this above. There. Then that is the variable, then the terminator. Then the last one you can guess for me. Now I want all these 3. Here it will give me the integer part. This whole value now get loveless will pull out the loveless out of that. So I say JLog int. There we go. Now you know it's easy. Right. Now let me run an example of Coxygen. Then you see how useful this testing code coverage is. If you don't do it, you run away from this Haskell, whatever. You run away. This is not yet even Haskell, but what I like with this is very readable. It's what we are used to with JavaScript daily. Syntax, you can follow it easily, concentrate on the logic. So I'm going to show you here. Let's go to, which one is good? Yeah, let me go to Cardano property solutions. Here I am going to kickstart one of these. I want you to see the on-chain part. All right, let me buy one of these. Yeah, here. So I'm going to buy here. Buy 150 years. Then it must pop up. Yes, let's go on. And then now let's go non-positive value, right? What do we have? Change that. I don't know. Hey, this one maybe there are no tokens to buy there. Remember, there is a bug I must fix there. Let me make this smaller. See total of 4. Let's say 4. Let's go. There we go. There we go. Perfect. Now let's go down. You see, this is what I was telling you. I'm not buying, but I just want to show you. Are you still online? Let me check. Are you guys still online? Israel.
Yes. Yes.
Yes.
Yes.
Guys, do you really see what I am teaching you? Because going forward, you will be the teachers and the developers using this Coxygen. I want you to watch carefully. You see this info, all this info from the beginning to the end.
Yeah. Yes, sir.
It helps. It's exactly what I showed you here. Here, this is exactly what I showed you. This. If you don't do this, then this is what is going to happen. Let me show you here. Let me just change here from this side. I'm buying. When you are buying, the only thing that it will say, it will allow or not. But I wanted to show you where now it fails because of some serious logic. Like maybe you are not the owner or somebody else. So I want you to see how that assists you to see the logic. When it's a logical error, this one is good. All right, this one is all right. Let me go to Mint. Actually, here I can't even Mint because there is no property here. Let me use another simple account. Login. So I'm going to log in here. Stella. Stella. Right. Stella has got no property. Don't think so. Stella has got property. There's no property listing for Stella. Yo. Let's go back. James. Does not match. Yeah, this one there is property here. Right. I'm going to run so that you see where there is a logical error here. I'll click one of these buttons. For example, I'll just jump and kick in the cancel. Let's run the cancel. I want to show you where there is a logical error, how that thing helps us. Yeah, like this one. This one you see here, it said false. The whole validation ran from the beginning till the end. It said false. One of the rules is false. Remember on the Boolean logic, if it's rule 1 and rule 2 and rule 3 and rule 4, if any of these four is false, everything is false. So now our problem is which of those rules is false? This is where this thing helps us. Because the first one here is the datum seller must be equal to the C dot seller. Now you see the datum seller, look at the datum seller, 2923. Look at the C dot seller. Therefore, these are not equal. Therefore, I know exactly where to fix. I must go and fix this seller to be this one. So I have to go and change the wallet account. If that JLog function was not there, it would just say false. And there is no error here. You see, there's no syntax error, there's no JavaScript of chain error that points to you what is wrong. You can spend the whole year not knowing where the error is. It will just say false. That is why I am saying we need to use the Jimba style. But you can check other things. The validator hash there is there. So if it says signed by the validator hash, then you know it's the validator hash is there. You can even go and check if right. This one, the CNFID, it is there. But there is a datum NFID. So I didn't compare them. So I have to go and check this again. But you need to do what we call code coverage in your testing. This one is very, very, very wide. Test each and every little variable across. So whenever there is something that doesn't go wrong, then we can check this. You will see it here. See it here. This one here. Okay. Let's try update. See what errors we are going to see. Go number 2, number 3. Yeah. Well done. Well done. This one gives us more. It's even brown this side. But the most important thing is the whole validation failed. Now let's step through. Seller value false. Already now, here is the first error. The seller value is wrong. Then we know exactly, we go to this line, property 5.4, seller value, then we fix. Here, you see here, the loveless, get loveless of, this one is 10. Then this side is signed by buyer, false. This one is not signed by the buyer. So the buyer must sign so that this is true. This is true. There are too many false here because I just clicked inner. And again, check here. The b.nft_id is not even equal to the datum.nft_id. You can see they are different. You can say, okay, you are at a wrong account. You are using. You are not even supposed to update this here. What about if I say sell? Let me run and say sell. Probably I'm not the owner. It's not going to allow me to. Yeah, I am the owner. That's why it's giving me that. Let's check this one. Did it run or fail? Let me load that. Okay, this one is the last one. Then let's discuss. Sell. Let me sell 40. Okay, sell 40. 1 out of 3. There we go. This one is stopped somewhere. Doesn't even. Maybe the function for selling is commented out because it ends at this button false here. Yeah, that is what I need to check. Why it's selling in the here it just comes and stops here. So I can check here. I think there are others that I'm selling. This one, let's try this one. 30. Let's see. Non-positive amount. All right. I will stop here. You guys, you need to ask. For me, I'm going to stop here. Let me stop sharing. Yes, let me hear from your side. I think you have learned quite a lot. The truth I will tell you about this thing is it's not like the normal applications we normally do. You are building a website, you are simply focusing on that HTML, CSS, and JavaScript the whole of your life. No. Here you are doing what is called an enterprise blockchain application because it's going to be used anywhere, anytime in the whole world, not by a particular organization, but anyone, anywhere who has a wallet. It's an enterprise application on blockchain. So it has got the following parts. The on-chain, that is the one that took me a lot of time here when I was coming here to just help you, say, use a smart contract. But now I realize I need to show you how to create that smart contract. And then in showing you how to do that, show you the playground for Helios, which we are using. Then I had to show you the book. The book, you know where to find it, know how to use it. Then show you how to create the datum. You saw it, how to create the datum, how to create the redeemer, and then in the body of the function of the validator. I showed you step by step how to create the cancel, edit the rules for canceling, and then how to do the withdraw, edit the rules for withdraw, and then from there, how to JLog to test. That is testing. How to test the execution. That is one part that I think you didn't have quite detailed information. The rest of the part, when you go to the code on the Coxygen part, is what you are used to because you're just calling a function that I created there. That function is not working, it is a bug, let me know, then I fix it. But for this one, the lock and unlock Coxygen was designed as an example for somebody starting to use Helios Smart Contract. Now you are building up an application I want the WIMS community to use, where 3 out of 5 signatories, they sign the money out and pay people. Donation app is fine, I'm happy with it. But it's not using a smart contract. That is the one I showed you how to create. So the two of you must sit together, draft first a simple smart contract with few rules. Put one rule, run. It's running. When it's running, go back, add a second rule, run, get it to run until you have got all the rules for security. What I will tell you, the lock and unlock functions will need you to copy them. Maybe copy them to the front side. Run them from the front. Why? Because you will need to add something there. The question is, what will you need to add? You will need to add the fields of the datum. The lock and unlock, you will see maybe there's one field, two fields. You will see how the datum was created using that one field datum on the on-chain. Now you have 3. List the 3. Check the data types. If it's a pub key hash, this side must be a pub key hash. If it's a byte array, this side it must be an array. If it is a int on-chain, on the off-chain it must be an int. But that when you bring to me, I'll tell you this is a data type error caused by that. We can troubleshoot together and get it done. But you have to do that. It sounds very complicated, very long, very impossible. No. You can actually do it within 2 hours. You just take one smart contract, lock and unlock smart contract, that one that is there. Add those 2 rules and they use it because it's working. That on-chain script for unlocking and locking, it's working. And the off-chain code is working. But now you need to add the data more signatories. and go to the off chain. On the off chain, you will see maybe a tx.8 signer, only one. Then you can say tx.8 signatories. Then you put an array of pub key hashes there. Right. So what else do you need clarification on?
Okay. We're also discussing the stake pool.
Yes.
Is Yeah, we're discussing about the stake pool. Israel did agree that okay, he can also be part of the team.
Yes, that one, remember, you are in charge of the stake pool. The stake pool now is easy because there are online cloud services we can create there. What I don't have time for you guys to come to me. When you come to me, and then I have to start teaching stake pool from the beginning till the end. For me to do that at this current moment, it means now I have to go and research stake pool the same way I've done with Coxygen. Do you see now with Coxygen, I was 4 months behind. Then you guys, some of you disappeared, went for exams, and they went in for assignments. What is the pain of working with students? Then
Hello?
I had to start putting up all my 2-3 months on this to fix it. So on the stake pool, Dylan, you need to move with it. Go online, research, get everything ready, and then come to me. Say, sir, we are going to show you how to create a stake pool. You take me from A to Z. I will ask you, check this. Then you discover what is missing. You go back over and over and over. The moment you get it right, and I'm convinced, yeah, you guys, you now understand how to run a stake pool, how to create and run and maintain it. Create, run, and maintain it. And then what will I do? Then the next thing that I will do is I'll say to you, all right, I'm creating an account for you on the cloud. And once I create that account on the cloud, then you go create it, then you start with it. But remember, it will be a demo and a test. You get it, move all around on the testing net until it is working. We are very clear, safe. Then we are going to get somebody to audit it because it's money, that thing. Can't let people stake on something that is not well audited. And I have to pay those people. Once we cross that, then we are going to put money there and we stake. Then we are going to request others to check it, keep on helping to check that the security is all right. But you will automatically be workers there because you'll be running and maintaining it. Then the moment it is working and it is safe, then the next thing, we go to those marketing people to start marketing our stake pool. We are missing a lot of funds from that because look, Cardano Foundation could have staked with us long back. If now Cardano Foundation recognized one of our applications as good and they voted for it, it means if we had done this the time I asked you to do diligently, we could be very far away. Are we together?
Yes, sir.
Any other question?
So okay. Oh yes. I remember last time you said you cannot do it on the cloud. Is it not possible?
Yes, now it's possible because the cost I on the cloud, the cost and everything were very high.
Okay.
But we need to get started. Now on the cloud, I'm able to do a what provision, a demo for you to work on. And then because we had a lot of load shedding, I bought those machines. They are still here. I don't even know what to do with them. Once one is running on the cloud, then we research on the cost, because remember the operational cost must be lower so that you are able, the stake pool is able to pay you and also have the same money for maintaining it, for paying the hosting, paying this and that and that and that. And then later on, we will decide if we need to buy PCs and then set it up at a what you call it, a server center. We research for the server center expenses, then we run it. But, see, all these, but Cardano has more than 3,000 stake pool operators. Those guys are running them every day, and they are getting paid. Some of them have got 90, 100 million at a state. So let's that one is a very big project. I don't want to lie. So if Israel wants, then Israel go online, research on stake pool, whatever. Yeah. Also, this one, get this one finished quickly. The moment I see you are delaying, then I'll have to start again and then do it myself.
Okay, I
Right.
think I'll
Any
create
question? You can't keep on waiting for Bill if he's not around. He's studying. Maybe he's found a job. You do it or get somebody to work with them and do it. I want you to manage the technical side until that moment. Maybe I get more experienced people to work with you as we go
Okay.
and grow. Yeah, like that. If you have problems, communicate. It's an area that you are the boss there now. So let's see how we move forward. If you are
Um,
available online, I'm available online. All right, Israel, on your side, what questions do you have?
Sir, what did you say?
What do you have on your side? What question do you have?
I have no questions, sir.
All right, try that. From my side, I'm done. I will stop recording you. I forgot we are recording. This is too long again, but no problem. I will try to upload these videos on Coxygen there.
okay.
Thank you.